right.
Okay, ready to go.
Sweet. Let me go ahead and share my screen. There we go. All right. Well, thank you everyone for taking the time out of your day to join me for my tech talk, which is teaching code to the next generation. Once again, my name is Andrew Russo. And you know what? I always like to talk a little bit about myself before we start. So here's a little bit of an introduction. So, believe it or not, I actually did not start off learning how to program. I actually started off as an English literature major studying at SUNY Geneseo and Geneseo, New York. Some of you may know what that is. Yeah, and if you don't worry about it. It's a cool little school. I enjoyed it. And yeah, right after I graduated, I actually ended up going to South Korea to teach English to elementary and middle school students in an after school program called Hagwon. So that's just like, English test prep, reading, writing. It was a really interesting experience, and I'll cover that a little more in a bit. But yeah, since then, I've been working in tech for several years in Portland, as well as operating remotely for different projects, different freelance work. And one of the things that I realized when I was doing remote work, even before COVID, is that it's very isolating. Like you didn't really do much. So I had the opportunity to teach at several after school programs, use teaching code, programming, and animation. So let's go ahead and begin and talk about the classes themselves. So each tech class was taught to students between the grades of kindergarten through sixth grade, teaching them the language Scratch. Now, let's take a moment to process that. Of kids as young as sixth grade learning to program. I mean, whenever I told someone this, they always give me a look that's a mixture of amazement and doubt, thinking, there's no way that a 6-year-old child can learn how to program. You're making it up. And I tell them, no, it's true. Um, it's absolutely possible. And here's how I ran my classes. So each class was a combination of going back and forth between game games, written exercises, and actually programming. Games to get them interested in what they'll be learning and getting familiar with the tools that they'll use. Written exercises to give them a little bit of a break from the screen and using their minds and logic more with figuring out what needed to be done and what needed to be altered. And finally, actually getting hands on with these programming languages, using them, building and coding with them in order for them to be able to reach the best understanding of what to do, what to make, what to create. And as I said before, all of these programs that I've taught are using the language Scratch. And from there, students have been able to expand into other languages such as Java, Python, and web development. In fact, I even had one student who I'm not sure how, but was able to follow and completely understand assembly language, which is a little bit crazy if you think about that. A fifth grader able to understand a language that, for me, was completely mind numbing and backbreaking. So, at this point, you're probably all wondering what Scratch is. I've mentioned it a few times, but you're like, I don't know what that language is. I've never heard about it before. Well, let me go ahead and tell you more about what Scratch is. So, Scratch is actually a language that was developed in the early 2000s with a grant from the National Science Foundation. In fact, all of you may have heard it as one of those little blurbs when you were watching Bill Nye the Science Guy or any of those shows from PBS. Hopefully, I didn't date myself just then, but the National Science Foundation was a foundation to help encourage the education and STEM interest for a lot of young people. And one of those was Bill Nye the Science Guy. But now we're seeing it in programming languages. In fact, this was a collaborative project between MIT's Media Lab and UCLA to develop a visual programming language using block-based programming. Yeah. And Scratch was created with the intention to learn and help students develop that logic and mindset to be able to reuse, remix, and share these programs, thus giving Scratch the catchphrase of imagine, program, share. Now, Scratch is a fairly old language if you think about it. Like it's over a decade old. However, it's certainly not outdated. Getting several major releases over time. In fact, the most recent major release was 3.x, being released in January 2019. So yeah. Now, you know what? Let talking about it is one thing. Let me show you a bit more about Scratch. So as I mentioned before, Scratch is a visual block-based language aimed for kids between the ages of 8 to 16 to help them learn about coding. And all of this is to help build the logic and foundation of understanding how code works, how it flows, and how it builds upon each other, much like how Java and Python works. And one of the nice features about Scratch is that it allows users to not only save their work using a login, as you can see right here, but also give them the ease to be able to share their projects. And for students, or anyone really, to be able to pick up those projects and learn how the code works, to be able to remix it, to recreate and alter using the Creative Commons certification. So let's go ahead and open a blank project. Let's see, is this going to load? Oh, I'm not signed in. You know what? That's my fault. But let's go ahead and create a blank project. Let's close the tutorial. So all projects are going to start off like this: a sprite. It's happy, but there's nothing here. But if we add a few different blocks, a few events, a little bit of control, a way for it to be able to move a little bit, and maybe change its colors a bit. Let's go ahead and change it a little bit. We can create a pretty simple program that loops itself, all within a few moments. It's pretty crazy, right? Like this is just a simple little program. And I haven't even scratched the surface with all these others. So yeah, let's go ahead and stop there. And oh, that's a lot. Let's go ahead. Let's do that. There we go. Perfect. Had to alter that code a little bit. But yeah, let's go ahead and go back here. So here are some of the blocks I used to build that program that you saw earlier. And this is probably what makes Scratch shine and makes it so unique is that each block is color coordinated. For example, those move blocks you saw, which allow the sprite to be able to move, to shift, to change its position, those blocks are always going to be that sky blue. But then we have event blocks, these blocks that start the program, sort of like you get an invitation to an event. If you get that invitation, that means you're going. No invitation, no party. So those are always in like the bright yellow blocks or the lighter orange yellow box. But then we have our control blocks. So the loops, the breaks, the blocks that allow us to be able to control our code, to allow us to be able to loop things through and to set things up. So like creating clones, creating copies, all of that. We have those in the orange yellow box. Then we have our color changing blocks, which are our purple. Those changes the colors, allows us to draw, to change, to alter, even change costumes or change the environment of our sprites or the background. And those are always going to be purple. Then we have our sensing blocks, which are I like to say sky blue, where if it's touching something or it registers a specific key press, it will register a certain action. And as you can see, these blocks are a different shape that usually fit within another block. And this is very significant when it comes to like registering a jump or when it touches something specific, sort of like the different levels in a video game. Then we have our operators. This is good for, this deals mainly with numbers, and this could be used for different things like having a character appear randomly on screen, an enemy, or or if you're playing like a number guessing game, having a random number chosen and stored within a variable. And of course, one thing that I find very unique and definitely is the big bridge are red function blocks that allow us to be able to create our own functions and have them separated. So that way it allows for cleaner organization. So this is just scratching, no pun intended, the surface of what this language can do. And this is the language that is a significant part of what I was able to teach these kids. To be able to help build that foundation, to be able to help them learn from this, to help them build up that confidence on being able to program and code. But it wasn't just that. There was other things that I had to do and learn along the way. Because when it comes to coding these languages, when it comes to teaching these languages, especially with kids as young as 6 or like, in like 4th or 5th grade, who, they may understand, but they'll struggle at times. It requires a certain level of skills, a certain level of understanding that you'll need before you're able to go through. In fact, here are just some of the things I've learned to handle when I was teaching some of these kids. Number one, well, not even number one, but one of the biggest things is just understanding the language at its very core. To be able to give an answer when a student asks a question, or to be able to help them on the fly whenever they have this request. To be able to know language back and forth allows allowed me to just quickly solve a problem that just may come up, or to help a student that may have a question that wasn't included in the original playbook or the original outline of the lesson, to be able to quickly respond, quickly refer, and to help them tackle that issue or concern that they may have. Um, that which is something I feel a lot of people, uh, especially in coding, may not have a full grasp of languages, especially if it's ever evolving and ever changing, like JavaScript and everything. Having a full understanding is a huge ask. But by having that understanding, by having that strong foundation and back knowledge, you can be able to tackle a lot that comes up, especially something that may just immediately pop up that no one is ready for. If you have that understanding and that preparation, it will take you miles far. The next thing I certainly said would say I've gained from this was being flexible, because there have been times I have set up an entire lessons teaching kids. I arrived at the school ready to teach, ready to show, and I found out those schools' computers are down for maintenance. So, what am I going to do? Well, come up with a completely different project, but still related, to be able to think quickly, to act quickly, and to keep these kids not only engaged, but keep their interest peak, so that they don't simply, you know, dismiss it, or they decide, this is boring, I don't want to do this anymore. To keep them involved, to keep them focused, and make them happy. And this flexibility also applies in the real world. If a problem arises, or maybe a client you're doing a project for decides to change something at the last moment, to have that level of flexibility, to have that understanding of what to do on the fly, will help significantly when it comes to not only your projects, but anyone else's projects you may be working on, or just helping someone who needs that help and they feel stuck. The other thing that I think a lot of people, I know for me at least, but some people feel, is the struggle of being creative, thinking outside the box. And when it comes to students, especially when it comes to like certain languages and certain like things they feel they can or cannot do, having that level of creativity, having that level of understanding can help significantly. One of the first questions I ask a lot of students is ask them what equals 4. And I always hear something different. Some students will say 2 plus 2. And it's like, okay, what else? It's like 3 plus 1. Yeah. And then 2 times 2. Yes. 5 minus 1. Yes. All of these equal 4. And the idea is that if the end result of any program or creation can be the same, but what lies beneath it, the code, can be different for each one. And this means that as a programmer, as a coder, you don't have to stick to the script. You can be creative and you can be flexible when it comes to building these programs. And this will help you greatly in the long run. And then we have perspective. Because let me tell you, kids have no filter. If there is something they don't understand, they will tell you. If they think a project is dumb, they will tell you. If they think you're dumb, trust me, they will tell you. So, one of the biggest things I learned when it comes to teaching, and especially with these younger students, is to be open, to be able to view things from their point of view. And this has actually helped me greatly when it comes to working with my colleagues on joint projects, but also working with clients who may not view things the same thing way I do. To be able to allow me to shift my perspective and to view what they may be seeing or to get a better idea of what they're viewing. That helps significantly in terms of collaboration and working together and resolving whatever issues may arise. And I know it doesn't sound like it's significant, but it really is to be able to shift your perspective and to view all of these things at once, to get all these different angles can help greatly when it comes to these types of projects. I just realized something. I screwed up. I didn't put the big one in this crud. Well, might as well talk about it now. So I would say the big thing, the number one thing, at least for me, that I realized that was big when it comes to teaching coding is patience. And this is big because I think this is one of the few that goes both ways. Because it's not only you, or it's only me being patient teaching kids coding who might be struggling to learn or, having difficulty with the code, but it's also patience for the students. Because a lot of the time, when some students are doing something, well, like when it comes to a game or when it comes to drawing or something, they are able to pick it up and they understand it immediately. But as all of you have probably experienced at least once, is that some things are just not that straightforward. You can't just immediately pick up something and immediately be good at it. It takes time. It takes time to understand, to get that foundation, to build up that logic and thought process, to be able to build up and get to where you want to be. And a good example of this is I had a student. Let's call that student Jake. And Jake was signed up for an advanced coding class uh, to so he could hang out with all his friends while not having any coding experience at all. So as I was teaching some of these classes where we are able to create games with like variables for levels and having characters spawn and move around a map using like tank controls, he was just sitting there. It's like, this is dumb. I don't understand this. Can we do something else? Can I play a game? And it's like, well, no, you can't. You need to be able to understand how this works. So I ended up actually assigning him a bunch of small little projects he can do outside of the class that he can do on his own. I told his mom, and he was there. It's like, this is dumb. I'm not going to do this. It's not going to make any sense. It's like, trust me. Yeah, it will. And next week, he came back up to me and he says, I understand now. I know, teacher. I can code. And sure enough, he was able to make significant changes to his code where he no longer was frustrated. He no longer felt like he couldn't understand. And he was able to get everything immediately because he took his time to understand those fundamental steps, to be able to understand how the code worked, and to be able to build upon it, which is huge when it comes to it. Because for me, I've taught many students, some as young as 5 years old, who could barely even read, and trying to figure out how to put these blocks together to make a sprite move 10 spaces. I've had students who, have been on the spectrum who feel like they can't make a mistake or else the entire program is ruined. I've had some students who have struggled with the same little problem over and over and over again, and it just wouldn't work. And yet, given the time, given the understanding, they were able to improve and build on it. But most importantly, I feel like with all students, they felt that pressure, the pressure that they have to get this right the first time, that they have to get everything working immediately, or else they have failed and ruined everything, which is not true. I mean, it's ridiculous to be able to put those expectations on a kid. It happens, but I don't. In fact, the first thing I tell students is like, you're doing this for the first time. Do you think you'll get everything immediately? And they're like, no. In fact, one thing I like is I always like to say this quote of one of my favorite buddies, Jake the dog. Dude, sucking at something is the first step towards being sort of good at something, which is true. To be able to have that understanding, to be able to have that flexibility and patience, to take time to learn this code, to make those mistakes is how we're able to learn, to truly understand what is going on with code, to be able to help not only us, but others around us when it comes to not only our work, but helping others when it comes to teaching. Because I will tell you, honestly, I have taught for quite a bit of time. I have met a lot of people who came in thinking, oh, this is teaching code to kids. It'll be easy, it'll be fun. And let me tell you, they do not last long. Not because they're not good teachers or anything, but more of like their expectations are not set. Sometimes they feel that they have that understanding and they can teach this, but they don't have the patience or the viewpoint or the flexibility to be able to help these students. And they struggle and then they leave. To be able to have that patience, to be able to have that sympathy helps significantly, not only here, but in other areas. I've seen kids who were meek and shy, not having the confidence in themselves, and then building these programs, having this understanding, building that confidence, and applying it to other subjects, their schoolwork, music, their passions. And you can see it. I've seen one kid uh, completely get absorbed into this and end up in getting an entire Lego Mindstorm set for Christmas. And let me tell you, seeing the absolute joy on his face, learning, coding, programming, all of that from these programs, from this base of putting essentially Lego blocks of code together is significant. You can tell I thought about this a lot, haven't you? Can't you? Anyway, I guess the big point is, would I recommend this? Would I recommend going and teaching these programming and coding skills to kids? Well, yes. I think that it is a great exercise to be able to take all of these skills and really put them to the test. Because there is no harsher critic than a 7-year-old girl who will tell you that your skills are terrible and really put things in perspective. Let me tell you, she actually had this coding skills to back up on that because my gosh, I think she ended up programming an entire like game comparable to Super Mario in like a week. So she knew what she was talking about. Regardless, taking the time to be able to take what you learn, to take those skills that might be minute and put them towards something like this will really help. Because not only are you building yourself up, you're building up the interest in these students to help them gain that confidence, to help build their interest, not only in tech, but in other areas as well. To be able to have that logic, to be able to tackle math problems, to be able to handle all these different requests, to be able to feel that confidence and not feel that worry or that those expectations that they have to succeed in order to be able to get it right. I think that's the huge factor when it comes to something like this. To be able to invest in the future, in the next generation, it's an investment not only in them, but in yourself. And I absolutely recommend it. Taking those steps. Now, not everyone will get along with kids. Trust me, I didn't think so at first. But taking those steps, taking that initiative to at least experience it, you never know. You might learn something new, and it might be for the better. So, anyone have any questions?
I think Michael earlier had a question on, let's see, what is the advantage of Scratch as a first language?
Let's see. Can you repeat that one? Oh, what's the advantage of Scratch as a first language? Oh, great question, Michael. So I would say the biggest thing about Scratch is the ability to just play around with the code, so that everything is color coordinated. So you know what blocks will do what. And that helps build in that logic, that foundation of like, oh, if I do A, B, and C, it's going to do G when I do this, to sort of build that foundation, to get them in that mindset. And that easily carries over to Java and Python and JavaScript. In fact, one of the summer programs I taught that was part of the same company was teaching Minecraft modding to students. And the interface we used for that was actually very similar to Scratch, where you could search for a block and it can pull it up and lets you like fit things together. Some things were certainly written in, but having that same format helps students get that logic to build into it. And the fact that it was Java of all languages helped significantly because students would be able to understand, like, oh, I missed something here. I know what I need to do to improve it. And then they're not like racking their minds thinking, what have I messed up? Why isn't this working? How can I not do this? Like me when I first started learning Java. Because let me tell you, that is a pain in the butt. Can we say butt here? I don't know if we can say butt here. Uh, anyway, so Michael, yeah, I would say Scratch is a fantastic language. Um, to start off and just get that understanding. Because I've seen kids go on to do other languages and other things based off of that, all because they have that confidence in themselves to be able to use languages to make those mistakes, which I think is the biggest thing that sort of deters some people from taking the step to learn coding, is they fear making those mistakes. Now, I don't think that applies to everyone, but I think it does apply to a significant part of people who are afraid to learn coding. Yeah. So yeah.
Awesome.
Do we?
It looks like we have another question. Sorry, were you still answering that question?
Yeah. All right. Let me.
If you look in the chat box, there's one more that says, what kind of qualifications do you need to teach kids? So what kind of languages, I'm assuming.
That's a good one. Yep. So when it came for me, besides having the drive and initiative to teach kids, each program is usually different. For me, one thing I had to go through was a background check. In fact, I am currently registered in the state of Oregon with a caregiver's license. So I'm actually able to work at like nurseries and like after school like facilities for like taking care of kids, because that's pretty much what the classes would be, is you are taking the time to watch over a young child while their parent will pick them up. So I was I did go through a background process in order to make sure make sure everything was good. But I would say the other big thing to go through is also just, being open and being open to criticism, to be patient and, flexible. As I, posted in those last few slides of just being able to let things roll off you, but also being able to address any issues that may arise. Like, for example, the whole thing where computer lab was completely shut down. I ended up actually having to teach kids how to make paper airplanes, because one of the nice things about that is there is a step by step process of going from nothing into something, and to go through those steps to be able to create a paper airplane that works. Similar to the peanut butter and jelly question that everyone gets asked for like every other tech interview. How do you make a peanut butter and jelly sandwich from scratch? Similar concept, but simplified. So.
What about some of the degree qualifications? Like, do you need a bachelor's degree, or what exactly would they require?
So for the job I took on, I believe you did need you did need a college degree. However, I knew some of my colleagues were actually students at the same time who were learning coding at PSU and PCC while they were teaching kids. So each company is different. Some will require you to have a degree, or at least I'd say at least your GED or a high school diploma, but it definitely does differ from case to case. Um, I feel like the biggest thing though is I feel like they want to make sure you truly understand the code and to be able to properly relay how the code works. Those are the two big factors that came when it comes to my job interview, at least. And when I was interviewing other people to take on the coding position, teaching position, that was the big thing too, is to see the code and then explain it to me like I was 5. So tell me, as Michael Scott, how this code works and why it's doing the things that it does. So, yep. Alright.
Great. Well, it looks like we have another question. So how is it different teaching code to new learners who are older, like in middle school or high schoolers, versus elementary age kids?
So, the nice thing about teaching coding to elementary schoolers is that they're kind of blank slates. So, you can really teach them some good habits, or what I think are good habits, at least. I'm gonna admit I'm a little biased in that. Good habits before they kind of end up doing anything like, getting stuck in a certain mindset or stuck there thinking like, I need to do this right the first time. Because that was some of the things I struggled with the first time I was coding, is that thinking of like, if this isn't right the first time, it's ruined. So having that level of like, understanding, having that level of like, patience and, willingness to make mistakes was a big factor. Whereas like when you get to middle school and high school, if they have been coding for a while and they already, you know, have some habits set up, some are good, some are good habits, but I'll admit there are some bad habits as well when it comes to certain practices. But also just being prepared to tackle some of those issues of like, you know, letting kids be flexible, letting kids be able to, handle different levels of difficulty. Like there are some lessons I prepared where I have difficulty level from 1, 2, and 3. Where level 1, I just want you to create something on the very basic level. Level 2, I want you to add levels. I want you to add a score so I can keep track of everything. Level 3, there better be levels, and with each background being different. I want to see that. So there are definitely different ways of tackling it with the levels of knowledge and depending on each grade. So yeah, I would say, at least for me, each case was different, but it was interesting. Um, Especially when it comes to tackling like teaching high schoolers, and it was something that I can see the wheels were turning, and I see they were really interested. Yep.
Okay. Okay, next question. So, what ideas do you have or might have that you recommend teaching kids who have receptive language disorder,
What was that last part?
who have receptive language disorder? So, I'm assuming. I think you mentioned earlier you also had students maybe with language disabilities or something like that.
Ah, yes. Yep. There was one time I had a student who was on the spectrum. I want to say he had moderate, I want to say moderate autism, where whenever he made a mistake, and I mean like snapping the one block to the incorrect spot, he would have a meltdown. I took a lot of time to, let him I made sure to focus on him and let him know that mistakes are supposed to happen, that he doesn't have to, feel like he has to get everything right the first time. And a good example was I actually ended up creating, it took me a day to do this, but I ended up creating 3 different sprites that all would do the same thing, but have different types of code. Like they would all spin and do something, but the code for each one was very different. And I showed him that, these are all different. Some of these won't work, some of them will. And it took me time to build something like this. So if you don't get it right the first time, don't worry. You have that time. This is the time to make those mistakes because I think you'll do an amazing job. So a lot of encouragement, a lot of, letting him know it's okay to make mistakes. And you can always ask for help. That's why everyone was there. And even better, you can have someone look at your code with you to help you. You're not going to be I told him that he's not going to be alone. None of us are really alone. I mean, look at everyone right here, right now. We're all here together to learn something, to be able to, get something from this talk and use that, hopefully use this information to help you later down the line. I mean, I really hope you use this information later down the line. But in terms of But in terms of communication, I did have one student who was deaf. So a lot of what I did was really focus on the idea of the color. I put a lot of focus in how the color blocks interacted, how each block was significant, and how they all fit and did a specific function. And I'll say I don't know sign language, but with a lot of body movement and a lot of, having kids have a chance to explore Scratch and play around with it, it helped significantly when it came to them, like where if there was something that I was unable to communicate with them, fortunately, they were able to figure it out on their own because they had that opportunity to explore the language and they had the understanding of what each block did to be able to solve the problem on their own. So that's another reason why I think Scratch is probably a fantastic language to start off with, is that it is forgiving. It is forgiving and it presents students with the opportunity to build that knowledge, to have that flexibility to be able to make adjustments on the fly, especially if the person who might be teaching you may be caught up on something in that moment or might not be able to say what you need to know exactly. Yeah. I hope that answered your question, Sherry. I really do. But if not, you can bug me later.
Awesome. All right. So next question, we have Brandon's question. So, what are some of the better innovations you have seen in the last 5 years for introducing younger kids to programming? When I was 13, I started my adventure in programming with Apple Script. Scratch is great for learning logic. How about actually typing out syntax or a visual based? Or is it just visual based?
Great question, Brandon. So Scratch is absolutely visually based. So there is no typing other than adding in text or did or no or some operators or some numbers, but nothing really written in there for syntax. I would say the closest thing to syntax in some of these would probably be the next level, which would be um, Java when I was doing the Minecraft camp. But because and but because kids already understood the logic in terms of like how the code flowed and how each part worked, they didn't feel like they were struggling when it came to understanding the syntax. Sure, it was another thing to learn on top of everything else, but they didn't feel opposed to it. And I will say, like with a lot of these languages, nothing was really written. It was all visual drag and drop and all visually based. But I feel like, for a lot of these students and a lot of these kids, having that understanding, having the ability to work out the logic first goes a long way and helps them understand and, gives them probably the biggest thing, that confidence to tackle some of these tougher languages that, you know, you do have to write everything down. You do have to type everything out. But if you have the confidence to be able to do that, I feel that's, huge compared to students who are just starting out in that area. Don't get me wrong, I was pushed into the deep end when it came to Java, and I learned significantly a lot for that and able to tackle other languages because of that pain, misery, and sorrow that I went through learning that at times awful, awful language. But, you know, there are definitely times where you want to take it easy, especially when it comes to, you know, students who you don't want to discourage them by immediately shoving them into the deep end. You want to build them up, have them, have confidence in not only being able to tackle some of these issues, but also confidence in knowing that they are going to fail, that they aren't going to immediately get it, and to try it again and again and again until they get it right. Right. Yep. I hope that answers your question.
All right, so the next few questions are from Sherry as well, just basically on how you teach, I assume. So, for example, how do you accommodate or encourage kids who are struggling to focus, or kids who are getting sidetracked or bothering other students? Or like, do you have any, do you share any rules you have before kids begin the lessons in the classrooms? So yeah, all from Sherry.
Oh yeah. So one thing is this lovely thing I call bribery. Mostly, I would not in the sense of like offering candy or anything like that, but mostly uh, offering them the opportunity to create something, or pulling sprites and assets that they might want to use and learn and play around with, using that as a signifier. Like I have an entire folder that is filled with different sprites from Pokemon, from like I think some different video game sprites. I think I have a whole folder that's like entirely like Fortnite and Legos and all of the stuff you can never imagine a 10-year-old and 7-year-old would want to play around with. All there. I also have I think I have an entire folder of like Disney princesses too for some of my girl students who, you know, weren't immediately drawn to coding, but showing that they have that option and, something that interests them and having them play around with that is significant. One thing I definitely enjoyed was having an entire set of like the classic 8-bit Mario sprites and tell them like, "Can you make this game?" And then I show them a game and sort of challenge them. It's like, "Can you make this?" So he can go from one end to the screen to the other and then jump on a platform. So those little challenges, bringing up those little challenges where it's enough to keep their interest, but not large enough where they'll give up halfway through because they don't think they can get to the end. Like those little milestones definitely are significant because it encourages them. It's kind of like achievements for and trophies when you play Xbox and PlayStation. Whenever you get that little ping, you feel pretty good and you want to keep going to get more of those little digital trophies. But in this case, the kids are learning something and they're gaining skills and confidence and you know they're challenging themselves. But also, I think they're mostly trying to get back at me to prove that they can do it, which I'm not going to argue against that. Yeah. Yep. So, sure. I hope that answered your question. And oh, I missed one. Ground rules. Well, one of the big things is raise your hand if you have a question. If you want to take control of another student's, if you're working in teams, uh, make sure you ask someone permission before you can take over. Uh, let's see, no running over the cords. That was a big one. I have a great story about that. I had a student who was a kindergartner who ended up, I showed him, like, see, these cables go from the wall to the projector. Please step over these. And I had one kid who did not listen to me and he tripped over those cables and he fell flat on his face. I didn't laugh. I just walked up to him, leaned down. As he got up, I can see he was about to cry. It's like, "You tripped over those cords, didn't you?" "Yeah." "You hurt yourself, didn't you?" "Yeah." And I see he was about to cry. So I pulled the ultimate move, alt line from this. It's like, "Are you going to cry right now?" And he's like, "No." And then he stormed off and started going on to the computer. And you know what? He did not cry that day, just to show me what for. So, yeah, I would say, what's the biggest rule? Other than just listen to what I have to say. Probably the biggest thing is don't be respectful for others. Don't do onto others as you don't want to be done onto yourself. So if I ever see a student, like, if I ever see a student who is acting up, which does happen from time to time, because remember, these are kids, I'll be like, what's going on? Are you going to be, is this who you are? Is this how you want yourself to be treated? They're like, no. And most of the time, that usually works. I haven't, I'll be honest, I've been very lucky and never had an incident where a student has acted up to the point where I needed to report them. So, yeah, I've always been very lucky in handling those situations, and I've always had a good group of kids. Yeah, I felt very lucky about that. Yeah. So I think that was the last question, unless there's any others, because I know we do have time for one more probably.
Well, Andrew, I'm the student director with the Tech Academy. I'm the co-host with Regina.
Hello.
I had some other work obligations, so I just came into the talk a little late. But sounds like a really good one. I am going to watch the replay of it. But I'm curious now, the teaching you're doing, is it volunteer or are you paid for it?
So the teaching I was doing was paid for. So it was paid for. There are certainly some organizations where it is entirely voluntary. I believe I want to say it's Girls Who Code. That one is entirely volunteer. It's been a hot minute since I've checked that one, but there are definitely a combination of programs that are, completely volunteer. But I'll say for a lot of my time and experience, mine was a paid teaching position. Um, and you know what? It was fun. It was like short lessons for about an hour, hour and a half. But I mean, I had a good time. The students had a good time. At least I hope they had a good time, uh, or else this whole presentation's kind of mute. Yeah, let's say they had a good time. How might you address
I'm sure
kids
they
who
did.
don't want? Yep. How do you address kids who don't share the keyboard? Oh, I just had a timer, and every 10 minutes, I just had them switch. And if they didn't switch, I said that they would pretty much be revoking their next time when they would get the keyboard. So instead of them waiting 10 minutes, they would have to wait 20 minutes. So, yep, that's how I usually set that up. And it worked out pretty well. I don't think I've ever had an issue except for one kid who was in the zone. But as soon as you like checked in with them, they immediately switched. So, yeah. But like I said, I had very good classes. I was able to handle them very well. So I've never had any significant issues.
Yeah, I will add one more thing. We've had students that.
Oh, your mic's not working right.
Yeah, it just cut out.
Oh, sorry.
Oh, there we go.
Yeah, what I was saying is we've had students that have volunteered and with teaching kids on the weekends. And I don't know how much of that is going on now, obviously, with things the way they are. But in the past, it's been really good for them to teach it. It helps with the students learning kind of to master something. It's best to teach it, I think.
Hmm.
And it's really good for their resume as well. So it's teaching is a really good thing you can do for kids and for your resume.
Oh, absolutely. Like I will say, I've definitely get a lot of comments where like people would look at when I was like looking for a more stable job, especially at the beginning of the COVID, people would ask like, "Oh, you taught. Who would you teach this to?" It's like, kindergartners, and they're like, "Wait, you're serious?" And then you break it out because it's a pretty big skill to be able to explain something as complicated as like negative numbers to someone who's barely able to write their name. Um, but if you're able to explain a concept, like think of it as like floors of an elevator. There's the floors that go up, and then there's like the basement where there's basement level 1, basement level 2, basement level 3. Just replace that B with a minus sign because you're going down. And it definitely strikes a chord because it shows that you have that flexibility, patience, and creativity to be able to knock something out in like 5 seconds, especially if something breaks down at the last minute and you can't do anything for 3 hours.
Yeah, and it's a good way to get back. So,
Oh, absolutely.
well, and Andrew, you can offer them NFTs now.
I mean, I thought of that, and then I'm thinking, like, what's a good way of giving them something that's minor while also destroying the environment at the same time? So, yeah.
All right.
Right.
Well, this is a very, very informative talk, and I'll share our YouTube channel with you guys so you can go check it out if you want to watch back the recording. But Andrew, someone asked what's the best way to contact you. I put your LinkedIn in there. Is there another way you'd like people to contact you?
I think LinkedIn's fine. I think I also have a Twitter as well that I haven't really touched in an age, but that's like the same. That's like, let me go ahead and put it here as well. Bruce. But yeah, I would say LinkedIn would be the best way. You can reach out to me if you have any questions. Just say, hey, I was in that tech talk that you gave, and I'm more than happy to answer any additional questions you may have.
Awesome. Thank you so much. And I did put that link in the chat box also for everyone wanting to check it out. Thank you again so much for joining our Tech Talk. But also, just to let everyone know, we do have another Tech Talk next week. We actually have Christopher Thompson, who has done a few Tech Talks with us in the past, and they're going to do one on machine learning operations. So I'm going to put that link in the chat box if you want to check it out and RSVP. Oh, also, let me share our Tech Talk playlist with you guys so you can check this recording and our past Tech Talk recordings. If you are interested, aside from the Tech Talks on that YouTube channel, we also have a bunch of educational videos. So if you guys are interested in those, go ahead and check them out. But this is pretty much all the links I have to plug in. Again, thank you, Andrew. And Brandon just put it in the chat box, so that's where you can check it out. But thank you, Andrew, and everyone else. Thank you for joining, and have a good day.
Thank you for having me. Take care, everyone.
Yeah, thanks, Andrew. Appreciate it.
Bye.